Sorry, I had some technical issues, so I will start over again with the answer on the paper. So in this video, we'll talk about the 2011 AP Calculus free response question number 4. So here we have a continuous function, phi on interval from -4 to 3, inclusive 2 quarter circle and 1 line segment, and we also have g of x. In part A, we have to find g of -3, g prime of x, and g prime of -3. For g of -3, we can just apply x equal -3 to the g of x function. So we have g of -3 equal to times -3 plus the interval from 0 to 3 f of t dt. We have 2 times -3 is -6. And we know that the area of circle is equal to pi r squared. So when we need area of a quarter circle, so we just need to take that and divide by 4, which we have 9 pi over 4. But be careful because we go from 0 to -3, so we have that part is equal to -9 pi over 4. Then we want to find g prime of x. We just need to take the derivative of each part in g of x. So we have 2 plus f of x. Because the derivative of an anti is just the original function. Now we have to find g prime of -3. So we just need to put x equal -3 into this function. So we have 2 plus f of -3 is equal to 2 plus 0, which is 2. So f of -3, the value of it is on the graph right here, which is 0. So now let's move on to part B. We have in part B we want to find the x coordinate of the point which g has an absolute maximum on the interval. So when you want to find an absolute maximum, you just need to find the derivative and original number. In the last part, we have g prime of x is equal to 2 plus f of x. So f of t. We can just put f of x right there. So we have g prime of x is equal to, just need to put, to find a critical number, we set g prime of x equals to 0, which is 2 plus f of x equals to 0. And then we can tell that f of x is equal to -2. Based on the 2 point of the line segment, we can find the slope and the equation of the line. So since we have f of x equal -2 right there, so we can just put -2 equal -2x plus 3. And then we can solve for x, which is 2.5, and that is our critical number. We also know that a relative maximum when the derivative change from the positive to negative at that point. So we can just check on that. So g of 0 is 5, which is greater than 0, which is positive. And g of 3 is equal to -1, which is less than 0, which is negative. We also we know that 2.5 is our absolute maximum. So we can just write because g prime of x greater than 0 for -4 to 2.5 and g prime of x less than 0 for 2.5 to 3. So g has an absolute maximum at x equal to 2.5. So just so you know, when we talk about the absolute maximum, we also want to check the endpoint. But in this problem, it's obvious that -4 is not going to give us the maximum because the area under the curve is, from 0 to -4 will be in a negative area, so that's not going to be right. And we already test the other endpoint, which is right here, which is -1, and it's not going to be a maximum either. So now let's go to part C. In this part, we want to find where is the graph of G has an inflection point. Just like finding the absolute max, we just want to think about the derivative. So we know that we have inflection points for the second derivative is 0. So G prime of x is equal to 2 plus f of x. G double prime of x is equal to f prime of x. So because of the graph change sign only at 0, so I can just write at 0. So G has an inflection point at 0. So because of the graph of x change sign only at 0, so G has an inflection point at 0. Or we can just look at the concavity because point of inflection. So look at right here. Like we concave up and we concave down right here. It's like positive slope and negative slope. So it doesn't matter which one, how you explain it. So let's move on to part D. In part D said find the average rate of change of f on the interval for -4 to 3, and they say there's no point C on that open interval for which f prime of C is equal to that average rate of change, and they tell it to explain why it does not contradict the mean value theorem. So let's deal with this two part at a time. First, we need to find the average rate of change. Then we will do the whole C thing. We talking about the average rate of change. Well, when talking about the average rate of change, we are looking for the average slope. Which is f of 3 minus f of -4 over 3 minus 4. This is just like slope between the endpoints, so it's equal to -3 plus 1 over 3 plus 3 minus -4. So 3 plus 4 is equal to -2 over 7, and that is our average rate of change. So let's move on to the C thing. We know that the mean value theorem said that f of x is defined and continuous on the closed interval from -4 to in this problem is -4 to 3. Then there is at least and differentiable on the open interval from -4 to 3. Then there is at least one number C in the interval. But in this problem, we can tell that this function is not differentiable because we have a cos right here. At x equals 0, the derivative is undefined, that means the mean value theorem does not apply. So we can explain like the mean value theorem was not contradicted because F is not differentiable at x equals 0. Yeah, so that's it. I'm sorry for my handwriting. Thank you for watching.